Hi guys, welcome back to the channel. I'm Dr. Downey and today we are going to be talking about the androgen receptor. In particular, the androgen receptor in muscle tissue. We're also going to talk about the hypothesis around androgen receptor downregulation and my thoughts on it. So when looking at the androgen receptor, yes, it's found in virtually all tissues, and when we isolate it to muscle tissue, we find that the androgen receptor is found obviously on myocytes, but not only that, on the surrounding tissues such as satellite cells, fibroblasts, the vascular cells responsible for capillary formation, as well as the motor neurons that innervate that muscle. When looking at muscle building, it's been found that androgen receptor expression in muscle tissue is positively associated with muscle hypertrophy and hyperplasia in men. We haven't shown that to be the case in women as of yet. One of the most important cells for muscle cell hyperplasia is a cell called the satellite cell. So firstly, the term hypertrophy refers to a cell increasing in size, and hyperplasia refers to cellular division and new cell formation. So when the muscle hypertrophies, it gets bigger just through all the cells increasing in size, and hyperplasia, it gets bigger because there are new cells. So hypertrophy is quite transient, whereas hyperplasia is fairly permanent. Satellite cells express the most androgen receptors in the muscle tissue. And on stimulation, whether it be by training or anabolic steroids, they differentiate and essentially divide and donate their nucleus to the surrounding muscle tubules. And this results in muscle hyperplasia. And what we have noted in studies is that when looking at different dosages of testosterone, when a dose of more than 100 milligrams a week is used, there is a significant increase in myonuclear, so nucleus density, i.e. relating to hyperplasia, in muscle tissue with increasing doses of testosterone. After 20 weeks, with a dose of 300 milligrams of testosterone, the increase in myonuclear concentration was around 5%, and with 600 milligrams of testosterone, this increased to 15%. So what we can see here is that hyperplasia is related to anabolic steroids, and with the increasing dose there's an increase in hyperplasia essentially. And this is just the first thing to note, that if there was downregulation with higher doses or longer duration, the dose-dependent response wouldn't be so significant. Although that's a weak argument, and I'll get into my other arguments later. So why do people think that androgen receptors downregulate with the use of anabolic steroids? Well, in the bodybuilding world, we use drugs such as clenbuterol, ephedrine, and all kinds of fat loss drugs that become less effective the longer you use them. They have a time period where they are effective, and then after a while the receptor becomes desensitized. And perhaps this led to the thought around downregulation of androgen receptors. There was one study that showed downregulation of androgen receptors, and this was done in the cavernosa of rats, and they found that with increasing testosterone levels, androgen receptors decreased. However, there is a massive issue to this study in that the way they increased the testosterone levels was through the use of finasteride, which blocked testosterone's conversion to DHT and therefore increased the amount of testosterone. So that's a major confounding variable. However, when we use in vitro studies looking at direct application of testosterone to cultured skeletal muscle tissue, we find that the androgen receptor upregulates. In addition, there are studies that show both testosterone and oxandrolone increase androgen receptor expression. Again, this supports that upregulation as opposed to downregulation occurs more commonly. And if we were to think about this in a logical way, those using TRT for long periods of time should expect to lose muscle mass with time as androgen receptors are downregulated. Because muscle cells require a constant stimulus if they are to stay the same size, and this is dependent on either androgen receptor expression or the androgens themselves. So if we look at someone who has gone off steroids, they tend to lose muscle mass because they're no longer getting the same stimulus. And this, again, would occur in the context of downregulation because there are fewer androgen receptors and therefore there isn't the same stimulus. So again, from a logical perspective, it doesn't make sense. From scientific perspective, with looking at research, it also doesn't show this to be the case. However, many use this to explain plateauing when building muscle, and especially with steroids, and that some individuals plateau at a certain point, and sometimes they blame this on androgen receptor downregulation. However, there aren't too many studies on this phenomenon, and I will look at it in a separate video, but essentially there are multiple different variables when we look at plateauing of muscle tissue. Limiting factors include your dosage, your training stimulus, whether or not that's increased or stayed the same, as well as other interesting things such as increasing levels of myostatin and androgen receptor sensitivity in different individuals. But I'll get into that in a different video. So essentially this video just gives you a little info into the androgen receptor, as well as why I think androgen receptor downregulation isn't really a thing. But let me know what you think in the comments down below, what your thoughts behind the whole muscle plateauing issue is, and I'll see you in the next video.